In this blog post, we are going to give you a look at the engineering diagram for, a screen enclosure type of structure. Nearly every project that we do that involves new construction has some type of engineering diagram, which must be certified or signed by a state certified engineer. The only projects we would do that don't really require that are rescreening and front entryways, shutters, stuff of those natures. But whenever there's a new structure that's permanent in nature going up, there's some type of engineering behind it. And most customers don't realize this until we, just give them a copy of their engineering that was used to apply for the permit. And then they take a look at it, and oftentimes there's many questions because the diagrams are very complicated, as you can see. So this post, or this video rather, is going to answer some of those questions. So we're going to start right here with number 1, where you see 11 foot 11 inches. Most people go right to this number and say, oh wow, this isn't the size that I wanted. In this particular structure, the size is going to be 14 by 30. And so they say 11 feet 11 inches, and I'm like, oh, that's not 14 feet. What's going on here? Well, the 14 by 30 is the footprint of the structure, so that's going to be the concrete slab size. This 11 foot 11 inches represents the distance of the new roof from the host structure's roof, or your house's roof, to the outside wall. So what happened to the 25 inches that would be required to make this 14 feet? Well, that's simply the overhang on your house. Most houses have a 2 to 3 foot overhang, sometimes as little as 1 foot. Sometimes some older houses will have no overhang, but most houses have an overhang. So this house had a 25-inch overhang. So when you have a 14 foot pad that's going to be your footprint, subtract the 25 inches that the house's roof overhang is covering, you're down to 11 foot 11 inches. And what you'll notice if you go over here to 1.5 is that if you add up the sum of each one of these little numbers, 5 feet 11 and a half inches, 3 feet and a half inch, 3 feet exactly, and 2 feet, right here is that you will be at precisely 14 feet. So when you're looking to, see what size the actual structure is, it's important that you add up, the walls as opposed to the roof, because the roof is getting some subtraction for an overhang. And in other cases, it's going to have, in this case, this structure here is a partial composite panel roof and partial screen roof. So this is like lanai with an open screen area. And in this case, there's even a little bit more overhang for the aluminum roof over here, which we'll cover as we go on. Number 2, you'll see right here is a door. Some people don't see a door on theirs, and that's okay. The door is not required to be on the engineering. We put that on there to help our crews, so they know precisely where the door is, but some customers really don't decide on where the door is until the last minute. So in those cases, we just leave the doors off, and since they're not a structural member, that's fine, they'll still pass. The only requirement is that they don't interrupt a structural upright, like your 2x4 right here. So if you don't see any doors on yours, just make sure that you get in touch with your project manager here at Gulf Coast Aluminum, and let them know where you want your doors, and they'll ask you to, before we started building. Down here at number 3, this is a frontal view of the structure. You see this little kind of chip off going out here to the side, and that's just a roof overhang. Aluminum roofs, or a composite panel roof, which you see here, have to have 1 foot overhang. Now this varies by each municipality, but as a general rule, it's a 1 foot overhang wherever there's no concrete. So on this side, there's going to be concrete underneath because this is still a screen patio. You don't have to have a 1 foot overhang here if it's going onto the concrete. And also this roof would be sloped out this way, so there really wouldn't be much water running off to these sides. But if there's no concrete at the bottom, there's going to be a 1 foot overhang. Let's move on here to number 4. Okay, number 4, you'll see a bunch of little details here, little numbers and symbols and stuff, and this is S1A4. This references a connection detail and what page it's on. These engineering diagrams often have 3 to 7 pages, and they're specifying what type of connections must be used. And at each connection, they're going to give, some type of indication about how many screws have to be used there, what type of cut must be used there, what type of plates or connection metal must be used there. Stuff like that, and the types of screws too, as well as the length of screws. Perhaps in another blog post we'll go in and we'll show you the connection details here, but for most people that, aren't trained at building these structures, the connection details really don't matter too much, and they almost look like hieroglyphs. But, it is important to note that even the connection details on your structure are all detailed out. Number 5, circled over here, this is simply the size of the aluminum. You can see right here that this is a 2x5, and that means that the aluminum member is roughly 2 inches by 5 inches. It's like a 2x4, and there's also, you'll see down here, there's a 2x3, and there's a 2x2. 2x4s here supporting the structure going up. So that's a real simple self-explanatory type of thing there. It's really just telling you what size aluminum member is needed to ensure that your cage meets its wind rating. Let's keep moving on. Number 6, okay, over here, this details the wind rating. You'll see right here that your ultimate speed is 150 miles an hour, and your nominal speed is 116 miles per hour. Now, why are there 2 numbers there? Well, the 116 miles per hour is the nominal speed, and that represents the amount of wind that the structure must be able to withstand for 50 years without compromising its structural integrity. Now, the ultimate wind speed here means the ultimate wind speed that it can sustain. But it's saying that at 150 miles an hour, there might be some compromisation to the structural integrity of the building. 150 miles per hour and 116 mile per hour winds are pretty much standard for nearly all of Florida. Some areas, if you get down towards Marco Island, you'll get up into 160, 170 areas. And stuff like that. Exposure category represents the amount of distance that the wind has to travel uninterrupted. So this, once you're inland, this really doesn't matter here. Now, as you get closer, towards the sea, where there's just big gusts of wind rolling in off the ocean, that's going to get higher. And these 2 factors, your wind zone and your exposure category, are factored into your price and your estimate. We consider all these when we're doing the estimate, because the higher your wind zone, the higher exposure is, the thicker the aluminum we have to use to make it meet the wind code, and the more screws and higher quality types of screws we have to use to get the connection details right here. Let's see, moving on. Number 7, right here, foundation design. This mentions what type of concrete it has to go on. Some cages require a footer, smaller ones do not. You'll see right here it requires 2,500 psi concrete and a soil bearing pressure of 1,500. So these requirements aren't too stringent. If you're building a new building, you're going to have probably a 4-inch concrete slab nominal with a 12-inch footer, probably 5,000 psi concrete or higher, and probably a minimum soil bearing pressure of 5,000. So it's not quite as stringent as it is for a host structure, but it's definitely going to ensure that your patio is staying down there. And we can also work with what you have. If you have a certain type of concrete slab that was poured at this, we can get these things engineered to where they will still anchor in there. In some situations, if you've got something that's, fairly minimally poured, maybe only 2,000 psi concrete, what we would do is we'd have to space the anchors closer together along the bottom. So if you go up to a real high psi concrete, you could get away with 1 anchor every 3 feet, whereas with this, you're going to be at 1 anchor probably every 18 inches or so. Going on down here to number 8, the specifies the gauge of aluminum that we have to have, 6005 T5 alloy. That's pretty standard for aluminum enclosures in Florida. If you go out of state, they'll use a lower gauge below 6,000, lower T as well. 6005 is pretty much the best on the market, and that's pretty much going to be standard for all of Florida. And down here, number 7, you see what type of screen they use. The screen can affect the wind rating, especially when it's used on the roof. So in the engineering, they do specify which type of screen it is. If you want a different type of screen on there, we can have your cage, engineered to accommodate that, and then the engineer will also note that. So that looks like all that we have, right now for this engineering. I'm sure there'll be many more questions that'll come out, from you readers. So if you do, just post them below in the comments, and I'll be sure to address those. And thank you guys for watching. I hope you learned something. Take care.